Hello, in this video I'm going to talk through quadratic sequences. Now the word quadratic is something that comes up a lot in maths. You might have heard it before. The word quadratic comes from the Latin quadratum, which is meaning square. So whenever you see the word quadratic, you're going to be thinking squaring is involved, and quadratic sequences are no different. There's squaring involved in a quadratic sequence. If you look at this quadratic sequence here, the formula is n squared plus 5. This one is 2n squared minus 1, and this one is 8 minus n squared. So whenever the highest power involved is squaring, you've got yourself a quadratic sequence. Okay, if you've got cubing or power of 4 or power of 5, then it's got a different name. But if squaring is the highest power that you've got going on, you're dealing with a quadratic. Okay, so first of all, what we're going to do is we're going to generate the first 5 terms of the quadratic from the formula. Okay, now just so that you're happy with the notation, because some of you might not have seen this before, un just means term number n. So if I want the first term, the first number in the sequence, I'm looking for u1, term 1. Second number in the sequence, I'm looking for u2, u3, u4, and so on. Okay, so that little subscript, that little underneath, that number underneath, just means whereabouts in the sequence you are. And in order to do it, what you have to do is put that number, that position number, in as n, substitute it in as n, and then work out what it is. So I'm going to go through the process in full for this one here, and then we'll talk through faster ways of doing it for the next one. So for u1, I'm going to put 1 in there for n. So I'm doing 1 squared plus 5. Make sure you follow BIDMAS, so squaring happens first, then the addition happens after. 1 squared, 1 times 1 is 1, plus 5 is 6. For u2, I'm doing 2 squared plus 5. So 2 squared, 2 times 2 is 4, plus 5 is 9. u3, 3 squared plus 5. 3 squared is 9, 3 times 3, plus 5 is 14. Then I'm doing 4 squared plus 5, and 5 squared plus 5. So my answers for those ones will come out 21 and 30. Okay. Now there's a really, really cool trick that is going to be helpful for us for quadratics, and you are going to need to be able to do this for later on. It's a really, really good trick that you can use as well to check that you're on the right track with them. So I would encourage you to do that. It's finding the differences between the terms, because there is a pattern with all quadratic sequences when you do this. So from 6 to 9, I'm adding 3. From 9 to 14, I'm adding 5. From 14 to 21, I'm adding 7. And from 21 to 30, I'm adding 9. Now, you might have noticed something with those numbers. They're different every time, but there's a pattern inside those numbers. You'll notice that each time, the number I'm adding is 2 higher. Okay, so with all quadratic sequences, you should be able to do this. If you find the differences, and then if you find the differences of the differences, which is known as the second difference, okay, you should always get the same number coming out. So for this sequence here, the second difference is 2. I'm just going to put a note of that here so that we've got that for in a minute. Second difference is 2. Okay, next one, we've got to do 2n squared minus 1 for the next one. So for u1, I'm going to do 1 squared, times it by 2, and then minus 1. Do make sure when you do this that you're using BIDMAS. So 2n squared minus 1, I'm going to do it in full. Let's do it in full for u3 so that you can see it for a more tricky number. I'm doing 2 lots of 3 squared minus 1. The process you have to go through is following BIDMAS. So you square first, then you multiply by the 2, then you subtract the 1. So do make sure you do it in the right order. So if I were doing full written method, I would write 2 lots of 9 minus 1, 18 minus 1 gets me 17 there. So what I would suggest you do now is pause the video and see if you can find the first 5 terms of these 3 sequences that I've got here for you. And I'll go through the answers in a minute. Okay, so looking at the answers to the first one, first of all for this one, 1 squared is 1, double it is 2, minus 1 gets us to 1. For u2, 2 squared is 4, double it is 8, minus 1 is 7. For u4, 4 squared is 16, double it is 32, minus 1 is 31, and for you 5. 5 squared is 25, double it is 50, minus 1 is 49. Okay, and I'm going to do all of the others and then we'll talk about second differences because it's important we remember to do those. 8 minus 1 is 7, 8 minus 4 is 4, 8 minus 9 is minus 1, 8 minus 16 is negative 8, and then 8 minus 25 is negative 17. Okay, and then finally we've got to do 3n squared plus 2. I'm going to write, to help me with this, the first 5 square numbers, and then the first 5 square numbers tripled, or 3n squared. So 3. All I'm doing is timesing each of these by 3, so I've got the 3n squared that I can then add 2 to. So there's no need to do it all in your head. So those are the square numbers tripled. I'm then going to add 2 to each one. So I should get 5, 14, 29, 50, and 77. Okay, so those are the 3 sequences that we've had a go at generating. Let's just double check that I've got the answers right now by finding the second differences. So 6, 10. Okay, so if I now find the second difference, the difference of those differences, the second difference of this one is 4. Okay, for this one here, we're going down by 3, down by 5, down by 7, down by 9. So each time we're actually minusing 2. That second difference. Okay, final one. Sorry, I'm going to have to move it up slightly so we can look at this one. We're going to add 9, then we're going to add 15, then we're going to add 21, then we're going to add 27. So we're going up 6, 6, 6. So for this one, the second difference is 6. Okay, I'm going to be ambitious and try and do an awful lot in one video and talk to you about how the second difference relates to the formula. So what we're going to look at in each of the formulas is how many n squareds are in there. So in this one here, there is 1 n squared. In this one here, there are 2 n squareds. In this one here, there's minus 1 n squared. And in this one here, there are 3 n squareds. That number relates to the second difference. This one, if you times it by 2, gets you that second difference value of 2. It's going to get very messy, I'm sorry about that. This 2, if you double it, gets us our second difference value of 4. This number here, the minus 1, if we double it, gets us the second difference value of minus 2. And if we remember the last one, we've got 3n squared. If we double that, our second difference should be and is 6. So if you double how many n squareds you've got, if you double the coefficient of n squared, you will get the second difference.